Hello, welcome to Unit 3, Lesson 1 with Professor Blackman. Today we're going to be talking about solving systems of equations by graphing. When we are graphing two lines, there's three different scenarios that could happen. They could intersect and have one solution, they could be parallel, have no solution, or the two lines could be the same line, so they're on top of each other, which means they have infinitely many solutions. If the graphs intersect, they are what we consider consistent. If they are parallel, we consider that inconsistent. And here, if it's two different lines, we will say independent. Infinitely many solutions, we say that those are the equations are dependent because it's the same exact one. All right, let's go ahead and look at some examples. All right, the first thing you want to do is take your equation and put it in y equals mx plus b. That way you can identify the slope. So we want to put it in this form. So that way here we can see the slope and the b is our 0, b, y-intercept. X plus y equals 4. Subtract x, and we get y equals negative x plus 4. And we take x minus y equals 2. And that's negative y equals negative x plus 2. Divide everything by negative 1. And you get y equals x minus 2. So this first one, I'll graph in blue. So start at 1, 2, 3, 4. And the slope of negative 1 is down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. And we end up with this line right here. Let's look at the next one. I'm going to graph that one in green. So y equals x minus 2. So start at negative 2. And up 1 over 1 is our slope of 1. And you can see our intersection point right there at 1, 2, 3, 1 is our intersection point. Now, because this is a system of equations, you should be able to check your solution. So if you take 3, 1 and plug it in the first equation, 3 plus 1 equals 4. Plug it in the second equation, 3 minus 1 is 2. So that is correct. All right, so again, let's start by taking and writing them in slope-intercept form. So 2x minus y equals 4. Negative y equals negative 2x plus 4. So y equals 2x minus 4. Let's look at the next one. 2x plus 3y equals negative 4. So then 3y equals negative 2x minus 4. And y equals negative 2/3 x minus 4/3. All right, so the first one I will graph in blue. So starting at negative 4. And a slope of 2 would rise 2, run 1, rise 2, run 1, rise 2, run 1. And we end up with a line looking like that. And let's graph the next one. So starting at negative 4/3. So right there. And then we're going to drop 2 and run 3. Drop 1, 2. Run 1, 2, 3. And so connecting those points. And when we look at our intersection, looks like it's right there. And that would be at 1, negative 2. And again, this is a solution, so we want to go ahead and check that. If we put in 1, negative 2 in the first one, that's 2 minus the negative 2, so 2 plus 2 gives us 4. Put it in the second equation, 2 minus 6, 2 minus 6 is negative 4. And so we end up with our solution at 1, negative 2. All right, let's go ahead and classify these now. As you see that these are two separate lines and they have a solution. Because they have a solution, we call them consistent. And because they are two separate lines, we will say that these lines are independent. It is inconsistent when they're parallel. So again, on this second one here, also the same. They are consistent because there is a solution. They are intersecting. And there are two separate lines that you can see, so we can say that these are independent. All right, let's look at another example. All right, this one's already in slope-intercept form, so the function of x, I'm on graph in blue, starting at negative 1, a slope of 1/3, drop 1, run 3, drop 1, run 3, and we end up with our line looking something like that. Graph the second one in green, starting at negative 6. And this is a slope of 4/3. So we're going to rise 1, 2, 3, 4, run 3. And I can see my intersection point right there. And we count out 1, 2, 3, down 2. So it looks like it's at 3, negative 2. Let's go ahead and plug that in. If I put in a 3 here, cancels with the denominator, negative 1 minus 1 gives me negative 2. Plug in 3 in g of x. 3's cancel, 4 minus 6 gives me that negative 2. So 100% confident in that answer. So let's start with this first equation at 6x minus 2y equals 2. And subtract that 6x, and we get negative 6x plus 2. Divide everything by a negative 2. And we get y equals 3x minus 1. So put that minus 1 there, and then a slope of 3, another point up 3 over 1, and you end up with a line looking like that. All right, let's look at our second equation. Start by putting it in slope-intercept form. And to do that, we need to move the 9x over. Divide by your negative 3. And we get y equals 3x and plus 1/3. So a positive 1/3 would be right there. And a slope of 3, rise 3, run 1, and you end up with parallel lines. So we can look at this one and we know right away, since these lines are parallel, there will be no solution because those lines will never touch if they're drawn a little straighter. All right, let's go ahead and classify these. These are intersecting lines, so these are consistent. And you can see two separate lines, so these are independent. In this example 4, there is no solution, so this is an inconsistent system. And you can see two separate lines, so these are independent. All right, let's look at our next example. All right, so we have 2x minus 3y equals 6. So that's negative 3y equals negative 2x plus 6. Divide everything by negative 3. We get y equals 2/3 x. Divide 6 by negative 3 and you get minus 2. So starting at negative 2 and a slope of rise 2, run 3, and you end up with a line looking something like that. Take the next one, 3y minus 2x equals negative 6. 3y equals 2x minus 6. Divide by 3, y equals 2/3 x minus 2. And if you notice, those are the same exact equation. So this is when we would say that these are consistent and these are dependent. And we have infinitely many solutions. Because any solution that is on one of the lines is also on the other line because it is in fact the same equation. All right, let's look at this last equation. It's one of my favorites because x equals 4 is a vertical line. And y equals negative 5 is a horizontal line. And you can quickly see where their intersection is, right there. Which, if you look, x has to be 4 and y has to be negative 5. So you end up with that solution pretty easily if you just look at the two equations. And this, of course, is one intersection, so we could say it's consistent. And two separate lines, so this would be independent. All right, that's all I have for you today. Happy studying.